So in terms of question number 22 here, so what is the subject of the sentence? So we're going to be able to identify the subject of the sentence. Very important. And so, which one? And so, which one of the inorganic elements here? So, inorganic means we cannot make it. And so, we're not talking whole foods. We're talking things that we can make. And so, inorganic means we cannot make it, so we have to consume it. And so, elements would be the key term here. So, the key word, the subject of the sentence. So, is a key component within erythrocytes, so within red blood cells, that facilitates the binding of oxygen for aerobic respiration. And so, given that we're talking which of these elements, not which of these erythrocytes, but which of these elements. And so, organic is carbon is organic. We can make carbon, but we need to consume iron. We need to consume zinc. We need to consume calcium. And so, iron is what we're talking about here. So why is it that when we look at question 23 here, which one of these elements, or which one of these inorganic elements, so one would be the subject of the sentence here. That's what I'm saying. So which one is a key element? And so which one? And so what are we talking about here? So the elements, so which one of these elements? And so which element essentially is a key component? And so which one of these elements? And so great job there. So question number 23 here. So when comparing, I should say, water to other molecules like hydrogen sulfide or hydrogen selenide, you notice that water has a higher boiling point. So what accounts for this? As we just talked about this, the hydrogen bonding. And so hydrogen bonding is what accounts for the special properties of water. So hydrogen bonding. So they're going to ask you about chemical bonding and balancing chemical equations. So let's make sure you definitely understand how to do this and how to work with chemical bonding. That makes sense. And so we have reactants. We also have products. And so in terms of this, it's the law of conservation of matter, which states that matter can neither be created nor destroyed, just transferred from one form to another. And so with that says that you have one calcium over here, you can't have 50 calciums over there. It's not magic. There's no pulling a rabbit out of the hat. And so with that, all we're doing is balancing the chemical equation to say that if I have one calcium over here, I need to have one calcium over there. If I have one sodium over here, I need to have one sodium over there. I need to have an equal number of atoms on the side as I have on the left side. And so I have one calcium here, one calcium there, we're all balanced. But now when I look at the fluorine, I have two fluorines on the side. I only have one fluorine on the left side. So that means I need to put a two in front of this one. This gives me two fluorines on the left side. That makes sense? And so given that, two sodiums here, I need to have two sodiums here. And so two sodiums on the side, two sodiums on the left side. Now two oxygens here, this subscript 2 says two oxygens here as well. This subscript 2 also says two hydrogens. This subscript 2 says two hydrogens. So on either side, we have two sodiums, two oxygens, two hydrogens, two fluorines, but also one calcium. So given that, we're all balanced. And so wherever we do not have a number coefficient, we're going to put a 1. So we'll put a 1 here and here. So this says for every 1 mole of calcium hydroxide that I mix with 2 moles of sodium fluoride, I will get 1 mole of calcium fluoride, and I will get 2 moles of sodium hydroxide. That makes sense? And so why do we balance the chemical equation? That's to get a mole to mole ratio. So a mole to mole ratio. And so what is a mole? So a mole is simply a box. So what's inside of that box? So 6.02 times 10 to the 23rd atoms or molecules. And so given that, let's say that we have X atoms. So we have A, we have B, we have C. And so A represents the number of moles, B represents the charge or the oxidation state, C represents the number of atoms. Alright, makes sense? And so with that, we should be able to identify what we have in terms of if they give us, say, for example, 2 moles of calcium fluoride, and so the 2 subscript with the fluorine indicates that we have 2 fluorines, and so the 2 outside means that we have 2 moles of calcium fluoride, for example. In this case, answer choice D would be the correct answer. So 1 mole of calcium fluoride and 2 moles of sodium hydroxide. That makes sense. So with that, what is the molecule that results when sodium with a plus charge combines with phosphate with a -3 charge? And so we're not do anything special here, look at your answer choices. These all have a zero oxidation state. And so with that, we need to make sure that we have a zero oxidation state or zero charge. And so they put a positive charge here, a negative charge here. So given that, we know that that they certainly recognize the charges. And so if the answer choices do not have any charges, then we should be trying to neutralize the charges. And so for every 3 positive charges, we need to have 3 negative charges, or vice versa. Since phosphate has 3 negative charges, we need to therefore then have 3 positive charges. For every 3 sodiums, that's going to be 1 phosphate, so Na3PO4. Answer choice C here. It makes sense?